Toronto in Canada. He is an AI and data analytics leader for Dell, and I'm talking about the great Bill Wong, who is here with us today. Bill is the AI and data analytics practice leader for Dell Technologies, responsible for supporting Canadian commercial businesses and public institutions. He spends his time developing AI strategies for firms, providing guidance on how to accelerate artificial intelligence development, working with universities and advancing AI research, and publishing a quarterly AI newsletter focused on AI adoption in Canada. Previously, Bill has held roles as an enterprise architect in consulting and AI analytics in development and product management during his tenure at Dell, Microsoft, Oracle, and IBM. He also published numerous books and white papers on advanced analytics and data management, and speaks often at conferences, and I'm always fascinated by the insights that he provides to us here at BTOES. Bill, thank you so much for sharing your expertise with our global audience today.
Thank you, Jose, and hi everybody. It's great to be here. And what we'll talk about today is architecting an AI ecosystem, and I'll present to you as enterprise architects, as I used to be, and really enjoyed my time as an enterprise architect, and I continue to use those best practices as I consult in the area of AI. So we'll briefly talk about where we are with digital transformation, and then we'll talk about the AI ecosystem. We'll talk about the hardware, the software, and I'm going to, where possible, talk about a use case that we can relate these to, and this is a live use case or a case study that I had the opportunity to work with at one of the hospitals here in Ontario. And then as part of the ecosystem, some of the questions that you'll be getting is, how will this integrate with cloud technology? And we'll end there. First of all, let's take a look at why Canada and AI. So if you've done any research in AI in universities, likely the papers will reference Canada. We're very fortunate to kind of be at the epicenter of the big boom for AI. ImageNet, that was done at University of Toronto, was the first time a team put together the compute platform and GPUs, new algorithms, well, at that time, neural networks, and then a large amount of data. And that just was kind of the big bang, as the NVIDIA CEO calls it, for AI. And it's been growing ever since. This recent survey about the Global AI Index was taken last year shows a few small countries here, the US, China, and the United Kingdom ahead of Canada. But, in all fairness, and if I was being realistic about Canada, while we're viewed as great innovators, we don't have the financial clout as the other countries do. And so the US, China, and UK, you're seeing lots and lots of investments and focus on AI. But Canada, we like to think that we're great contributors to this movement. Now, regarding digital transformation programs, this is taken out of a survey that Dell does every 2 years. And on the right-hand side of your screen here, the 5 top programs. Cybersecurity continues to be the number one, no question on that. Very important in the age of the internet. Remote working, again, from the last year and a half, everybody's had to work through. Again, no surprise. And where I come to is number 4 here. And so there are lots of great digital transformation programs, but you'll always find that leveraging data is in typically the top 5 of investments that people want to improve. This is technology that people think they can really differentiate their offerings. As part of the survey that we do every couple of years, we also ask, what are your key challenges here? And not surprisingly, data privacy and security. And as we go forward, I think they'll continue to be very important factors. Now, last year perhaps accentuated the need for funding, and the pandemic actually increased funding in certain sectors, and we'll talk about one of those sectors, which will be healthcare. And then finally, number 3, this is an ongoing challenge for many firms, large and small, is how do I extract insight from my data? And we'll talk about some of the recommendations we have. Now, I'll start here rather than concluding on why enterprise architecture is so important, especially in the field of AI. And the leading firms will have enterprise architects leading innovation, and that's 24%. And if they're not leading, they're certainly part of it. And there are firms that we call laggards where EA teams do not participate, which I think is an error on their part, because the EA is a unique role where you have a holistic approach of how the business works and what's of value to the business. I had a meeting with the CTO, and the first question I had, after he explained what his challenges were, I asked him, do you have an EA? And they said no, that they were looking. And fortunately, they did hire one, and that EA reports directly to the CTO. And again, that's a best practice that I have, is that a person with these kind of skills really needs to be involved in these kind of programs. So a bit of a paradox that we're seeing, and if you're interested in learning more about this, I'll be presenting about some of the paradoxes we see out there. There's no doubt that companies think that AI and data analytics is important, as you see by this chart by Gartner on the left-hand side. But the paradox is that while they say it's important, the investments continue to lag. And there are many reasons for that. But in the industry that we're seeing today, there's still kind of, they say it's important, yet they're not fully both feet in investing in. But there are significant investments, to say, in AI, and right now it is the largest growing footprint in the data center. Now, AI, these hype cycles dated 2020, and I took a look at what Gartner's writing in 2021. They should be out shortly, but there's not too much change here. If you take a look at the second half of the right half of the screen here, so there's going to be a focus on generative AI, and this is the technology that can create deep fakes, how to combat that. You'll hear terms like composite AI more, and that term for more container-based and using AI from individual projects, combining them, as well as adaptive ML. That's a term that we're starting to hear for ML programs that are changing and adapting based on real-time data, not just based on historic data. Now, as an EA, I go back, I used to use the Zachman framework, for those of you who go back that far, and but I do like the TOGAF approach here. So if you are based in that kind of background, where you have an application, data, technology, architecture, or business architecture, I find a lot of companies respond to that well. So what I'm going to do is take you through kind of a case study here and some of the artifacts that we created here, beginning with the vision and use cases, understanding and documenting for the stakeholders what the current environment is, talking about what is the art of the possible, the target architecture. Based on time, I'm not going to get into details on exactly the steps on the strategic roadmap. You're free to ask those questions if you like. But again, it's part of any kind of transformation, governance. Very important to have that as part of the program. So, so this is real live artifacts, not just created for this presentation, that we did present to the C-level executives for this hospital. And their vision was to create an AI center of excellence, a sandbox where researchers would come in with their algorithms to test them out. Their environment was that every researcher, and they have about 30 projects going on, everybody was doing their own kind of mini IT project. Everybody's using different algorithms, everybody's using different hardware, everybody's getting private data. And they thought there's got to be a better way to do this, to save money. So they looked for opportunities to standardize, consolidate, and they really wanted to get deeper insight. So there's a lot of data locked in proprietary type of databases. If you're in healthcare, you will have heard of databases called Epic. They have a lot of healthcare data, but very difficult to access. And so when we talked about possible use cases, AI has really kind of changed the landscape of what's possible out there. What some of the things the hospital is looking at and what consumers were demanding is, hey, can I use my Fitbit? Is that useful information? So lots of smart devices there. People have personal devices, but also at the beds, remote monitoring. The hospital that I was working with also had a huge research arm and a teaching arm. So they're looking into augmented reality today to help doctors perform, let's say, surgery, and it's all done virtually. So that technology is being explored today. Virtual assistants for frequently asked questions from patients. As well on the right-hand side, digital pathology, precision medicine. These are all things are enabled by image recognition, AI algorithms, and neuroscience as well. The use case as part of this transformation exercise, the one that they wanted to focus on was reducing emergency wait time at hospitals. So it's a bit of precision medicine, and right now, like wait times is in the hours, that's not bad, but they thought, hey, we want an opportunity really to reduce that. On the bottom there are kind of what business drivers the institution had. So they want to be known, and one of their charters is to deliver the best patient care possible. They also wanted to foster research and a great learning environment for new physicians, and as well do new types of research. They have an HPC cluster available to their researchers. Now, this is a kind of a set of architectural principles, and typically when I get involved in developing a strategy, usually I see about a dozen architectural principles listed out, and these are things that help design and help the team select what technology they want to incorporate. So it's a useful thing to set up front. And these are high level. You want to adopt open technology. Of course, you want something that can perform and scale, etc. But you want to get sometimes to that next level of detail here. And I'll talk about the ones that were relevant for this project. So always useful to put out what your current state is. And outside of listing the assets here, it's good to paint a picture on what the key challenges are with the current state and the model development. So again, I mentioned before, each researcher kind of does their own thing, but as well, they're challenged. Outside of just developing in Python, there were no tools to automatically promote code into production, and then to what happens after you deploy in production. Can I monitor, etc.? Do I have to change the model? Another thing they found here with their researchers is that there was a big opportunity to somehow consolidate and standardize data. Everybody went after their own data set. Everybody had to vet it. And data really wasn't a shared resource there. And even if it becomes a shared resource, as we've seen a lot of firms go, where is the data? What is this data? And so we'll talk about what best practices are here now. And then finally, we saw some very inventive solutions on people on where they got their servers and storage infrastructure. Many had it something under the desk. People were borrowing, and stealing this. Some people were going to the cloud, etc. There was no standard infrastructure out there. So on the right-hand side here, again, these are some of the requirements that came out when we talked to the researchers, as well as with IT as well, is a platform that they could leverage that's scalable, that will perform and support their favorite tool. Okay, so now as part of the ecosystem, people have a choice on hardware, and why that's important is that for some areas of medical research, some of these require just an intensive amount of compute power. So I'm not saying that for all AI type of work, you have to pick GPUs. However, having said that, if the work is really deep learning intensive and really needs kind of the best and the latest algorithms for natural language processing and image recognition, likely it may skew toward GPUs. But today there is a breadth of choices on your far left here. CPUs, which everybody's familiar with, it's the chip that powers your laptop, and the big players there, Intel, AMD. And the advantage of this is everybody's quite familiar with applications that run here. And then as we go to the right, you get more specialized processors here. So NVIDIA, really the 800-pound gorilla when it comes to providing GPUs. And then FPGAs, field programmable gate arrays. This is more flexible, but you have to code at the firmware level. So we don't see as much adoption here, and we do see some adoption in certain industries. And then on the right here, on the far right, are ASICs, or application-specific integrated chips. These are chips that are specially designed to run deep learning algorithms really quickly, efficiently, takes less power, should be less expensive. Most of these will be in IoT devices where they build the intelligence there, but there are places, companies like GraphCore, a unicorn from the UK that has done deep learning and claim that they are the fastest server out there. And at Dell, we're one of the only ones that offer that choice there. But there's a choice, and again, this should be driven by the workload. Other things when you develop an ecosystem for your environment is to understand what kind of trends are out there. So we understand there are this new technology, those AI hype cycles, new types of algorithms. Also, what we're seeing a trend is kind of a merge of workloads. And if you have experience with simulation workloads running on HPC systems, there is this new kind of data pipelines that requires both simulation and AI deep learning algorithms. So one example of this in healthcare is actually research that was done to better understand and to create a virus against COVID. So they used actually AI to predict the molecular structure. And if you have a background in structural biology and chemistry, the approach they take is they want to develop an inhibitor to the virus. And in order to do that, what they really like to do is understand the physical structure. And that's why it's important to understand that 3D structure there. Once you have that, rather than going to the wet lab and actually testing this under a microscope, and you want to do this in silico, in computers where possible. And that's where you need lots of power, compute power, and HPC does these protein simulations. So very compute intensive, and it's a great feat that they were able to produce this vaccine in the short amount of time they did. But I will tell you that in order for them to create that, massive amounts of compute power were used across the world. And it's great to see if you're in this field, there's a lot of collaboration, a lot of sharing, a lot of companies giving up cycles, free compute power, just so researchers could better understand the structure of the molecule and what would inhibit the virus. Now, for a lot of companies, they're looking to machine learning as a service, or what kind of software tools are out there. And for the first time, the quadrant on your left, they actually put the cloud vendor tools with the on-prem tools. And most of the cloud vendor tools are in the bottom right-hand corner. Today, with today's technology here, the best tools appear to be, by adoption, are the on-prem tools. Not to say the cloud vendors are going to stand still there, but today I think it's fair to say the on-prem tools have an edge, better integration with the development tools. Now, as a foundation, very important to have a data platform, and this should be optimized for the industry and for the workloads that you're going to support. So for healthcare or medical research on the far left here, these are the kind of data sources that you see. And in this use case, the EMR or your electronic medical records, this is the kind of data that's held in Epic databases that we're trying to extract. And we wanted to extract it in real time, which means that we needed a streaming solution as well. So yes, and that in itself was an interesting exercise. But as you can see, there are other types of data here, from research papers to real-time monitoring of patients, medical imaging. These are very popular data sources that are being consumed today. And as you move to the right, what you want to do is create a platform that will ingest this, enrich it, curate the data, and then make it available in a platform that will perform well for the personas that we see on the right. And in our use case here, we really want to make this available for both researchers and the clinicians, the people on the front line. And part of this ecosystem, is another way of putting it, is selecting vendors that kind of meet your architectural principles and then listing them. So you would not pick a platform with all these tools. These are just examples of tools that you could pick. Let's say let's pick in the middle, streaming solution. So Elasticsearch, Splunk, very popular tools. Kafka, if you're going open source, etc. And then as a data lake, Cloudera, very popular for Hadoop. In our use case, it was interesting. This hospital did not want to use Hadoop. So if you're familiar with Hadoop, a very popular platform for unstructured data, but this hospital thought that there's going to be newer technologies that want to be tied to Hadoop. So they just picked object storage as the storage device going forward for unstructured data. Just a couple of points about the cloud I'd like to talk about is we're seeing a lot of companies kind of doing a pause here. And I see a lot of firms that they have mandated everything's got to go in the cloud, everything's got to go in the cloud. And I think what people are finding is, well, there are some benefits putting everything in a central spot, but the original ones about saving money, that seems to have fallen by the wayside. A lot of people are going toward cloud really for to try to be more agile, time to market, and which are great reasons, but cost isn't necessarily the justification for cloud. And what they're finding is that in some cases, especially with AI, the costs are quite dramatic on where you place the data. So if you're training an AI model to do, let's say, image recognition here, I have one firm here in Ontario who will tell you that it's at least a 10-fold difference. And so what we're seeing is most firms are picking a hybrid approach. Many like to develop Some like to develop on the cloud as well, but if you have a lot of data, they put the development on-prem, and when they finish with their model, they put that to execute production in the cloud. And so they step back and ask themselves, okay, what makes sense? Where should the data go here? And especially with healthcare type data, many of the hospitals are very conservative and want to make sure they get the best security, and they put that on-prem. Not to say the cloud security isn't as good, but they just want to, it's like a security blanket, they want it right there. Public cloud adoption should be no secret that AWS has the market share leadership, has had for a number of years. Azure's number 2, and actually Azure is actually doing better by comparison in Canada for some reason. Not sure why, but relatively speaking, they seem to be doing better here. Number 3, Google Cloud. And number 4, which probably most people don't know, is VMware. So the VMware folks, the virtualization technology, you can build something and it'll work together with containers and migrate that seamlessly to the other cloud platforms. So for your reference here, I've listed for AI and data analytics type of applications what each cloud vendor would offer there. And just because they have an offering, it does not mean it's the same capabilities, functionalities as its neighbor column there. You really have to kind of understand what are the functions that you're asked to deliver, and then take a look at who's got the best mousetrap. Now, in addition to AWS, Azure, and Google, I have listed things that Dell offers, and Dell's approach here is really to partner with best of breed out there. So most of them in that column are independent software vendors, because Dell really doesn't own software. We used to own a company called Boomi, and they'll become independent the next fiscal quarter. And then lastly, in the last column, open source. Keep everybody honest. Don't pick any of the hyperscaler offerings. You can pick open source. So with that and understanding all that, then we try to craft our future state. And what we're moving toward here is a model-driven environment. And while I know a lot of folks like to code in Python, a lot of people do not like to. There's an equally large amount of people who don't want to code in Python. And likely what we're going to see is more and more tools that don't require coding. And really to get more citizen type of data scientists to be able to create these applications. So machine learning as a service, to reduce that time, developing that from months to weeks. And then, as I mentioned before, in the middle layer here, this data service. You have all this data, and if you do manage to consolidate it all, how do you figure out to where the data is? And the technology that's come out of late is this data cataloging. And there are a number of vendors out there, and Boomi has a data catalog capability. But what you want to do is to try to remove IT from the equation, have a self-service portal that researchers can come in, your data scientists, and they take a look at a menu and say, okay, here's the data, pick this data, and description, dictionary glossary of what the data means. And so companies are using that today. And then finally, platform as a service. How to deploy the infrastructure, which includes hardware, software, using and leveraging Kubernetes, having everything kind of containerized. And so, as I mentioned before, for this project, these were kind of the main architectural principles that guided their selection of technology. They wanted to be agile. They wanted best of breed. They didn't want one vendor, either cloud or on-prem, to provide all the tools. Other things, open source tooling, I mentioned before, hybrid. So they recognize that there is use and benefit of the cloud, but they didn't want to go all in on the cloud. This is just to highlight some of the resources that Dell can bring to bear when it comes to AI. We have a bunch of data scientists that I leverage, and this is a place just around Austin. So we have a supercluster there made up of GPUs that I've leveraged for one of our universities, a supercluster for AMD processors, and a supercluster of Intel. So whatever the workload, whatever the customer's inkling or favorite platform is, we help test those algorithms out. And it's a service that there's no charge for. So this is my last slide. And what's the best practices here, some of the things that we learned here is one is to adopt this data-driven culture. It's very important that the benefits of doing this, before in the past, sometimes in some organizations I've seen is they guard their data really closely. They don't want to share it. They think that it's more valuable. They're more valuable. And they have to go through you. But in this day and age of a data-driven world that we're going into, you're going to get more value to more people if you share it. I know it sounds kind of simple, but in one of the hospitals I was working with, the government, they written a paper, a great paper talking about what their digital transformation strategy is, and then another great strategy paper on what their data architecture should be. But when it came to execution and practice, what we found is the IT people really guarded the data, and they would say, hey, it's private, we're not going to share it. But the people who could really use the data, and these are researchers working in healthcare, say, hey, we need that data, so we can kind of build these models. They couldn't come to bear. They couldn't unfortunately agree on how to do it. So as many of us have probably seen, what happened is these researchers, their line of business, they have their own budget. They bought a cloud database. So they created another silo of data. And they brought me in to try to say, hey, while it's great that you're driving this, what you are is kind of making the problem more complex here. You really got to find a way to kind of work together. So again, sharing data, best thing to do. And then as an enterprise architect, take an architectural approach to this and involve the stakeholders. Make sure that there are business stakeholders, researchers involved, that this is not just an IT-driven project. And we didn't get into details on the governance, but again, if you have a tool like a data catalog, those tools help automate and make people adhere to governance policies. So whole bunch of vendors there. Again, pick the ones that are best for you. Strategy that we have here at Dell is we want to be an open player here. Okay, that's it for that. Now we can move toward Q&A.
Excellent, Bill. Excellent. Bill, I'm gonna ask you to do me a favor. Actually, keep the presentation sharing because someone asked about slide number 22, the one where you put the different vendors and the providers there. Yeah, would you share that one momentarily?
Sure.
The list, I know you have asked the question. Others have pointed out to this slide as well. You have access to the recording of the presentations, but you can go ahead right now and take a screenshot here. They thought this was an incredible, insightful data that you were sharing with us. And thank you for doing that. It's great work here and kind of distilling down the options and they're available there for different levels of processing and applications. So just the audience asked if you could give them a little bit of time. So I'm assuming that by now people have taken the screenshots if they need to. But this is very great, very generous of you to compile and share this level.
Yeah, I'm happy. Some people have found it of benefit. I did take a lot of time to create that in my kind of after-hours job, I guess. And it was kind of fun too. Having worked um, at, at Microsoft, kind of knew their tools. And here's the thing. It's funny. If you try to do this yourself, what you'll find is some of the companies here have changed the names, even though it's the same tool. And here's kind of a litmus test that I use for companies. If the company changes the name of the product repeatedly, it tells you that they're not happy with the market adoption. That's kind of one of my rules of thumbs here. So some of the tools here have changed 2 or 3 times the name. Same tool. I don't want to call them out, but when unfortunately for some reason a lot of marketers and technology think if they change it, kind of repackage it, maybe again it'll get better adoption or sell. So as far as I know, these are the latest names. I always have to keep checking, but if not, apologies, but I do try to keep it current. If you're interested in getting the full presentation, feel free to look at my profile on LinkedIn. I will be posting this presentation up there as well.
Fantastic. Fantastic. And of course, you also receive an email with a link and password to Bill's full presentation, not only the slides, but his color commentary on everything. So, Bill, fantastic. So you may now stop showing the presentation screen. I'm going to come back on here and relay some of the other audience questions to you. If you go into the GoToWebinar interface and just hit the button that says stop showing screen.
Yes, I'm trying to bring it up right now and I can't find it anymore.
It can happen. It can get hidden behind applications sometimes. It's under, if you see that little red arrow, just where you toggle your camera off, to the right of that is where the tabs should be.
Yeah, and I see the sharing and I found it. Thank you.
There you go. There you go. Thank you, Bill. Bill, so we have a few minutes here for the questions. I'm going to start with one of the themes that has emerged, and it's kind of an overall catch-all real type of question. If you have a blank slate, if your company, has not really become serious about developing an AI ecosystem, there may be a little application here and there, but you have not really built the AI ecosystem. What would you do to implement in a way that, that's not a large implementation scale, but something that you start small and scale? What are some of the things that you think that organizations need to take their time to get right up front and then in building this AI ecosystem?
Yeah, great question. My recommendation, and I do get requests from customers, questions exactly that. Where do we start? Like we know it was like cloud was when it was first introduced. C-level execs are going, what's our A strategy? What is it? I still think from an enterprise architecture approach, you have to build a strategy. I know you're going to start small. And the first part of that strategy is to get and line up with an executive stakeholder and pick a use case that's going to get high visibility, that's low risk. I know that's asking a lot. Usually the higher risk ones means it's much more difficult to put out. But look for those use cases where you can get a quick success story, and that'll help get people on board behind it, because I'll tell you, this is not an easy task. This is one of the most challenging technical things you can do out there. But the rewards are, I think, are worth it. Why everybody's so interested is literally transforming a lot of things that we're doing out there. So again, like you said, Jose, start small, but something that is high profile. So for banking, something with customer experience, customer insight, with healthcare, something that a frontline person, a clinician will benefit, or a patient. And it doesn't have to be difficult, really complex. So here's an example, hospital I was working with just a couple weeks ago. What they found is where certain weather patterns, they have found that they get more people coming into the emergency ward, and those weather patterns tend to be like thunder, or really kind of harsh ones. And even though they have all these weather programs that they adhere to, it's never good enough in terms of predicting. And so they got their own IoT devices, or maybe they leverage it from the government, and they get that data stream and they feed that in and then to their model, and they combine it with something else to help them do resource planning, so that when certain weather hits, as soon as they get an inkling that it's coming, they've got more doctors on staff and nurses. It's a simple thing. It didn't take them more than a week to put that together. But something like that, people are going, oh yeah, this data stuff is good stuff. To be able to combine that data with their resources, this IoT feed, it's just such a simple thing, but really high impact. That's the kind of application you're looking for.
That's very good. The other question and theme that has emerged is related to the open source versus proprietary algorithms, AI engines. What does the landscape look like today, in your opinion, with open source AI and then proprietary? I know that this can be like very application specific and very industry specific even, but just if you paint a broad picture of how open source AI versus proprietary AI continues to evolve, what is your assessment? What does it look like today?
Yeah, well, this field is changing so quickly. I think open source has the advantage of getting things out there quicker, usually because the commercial ones want to test things out. And this is the kind of field that I've seen that kind of merges a lot with academic. In a lot of areas in computer science, you don't see things from academia until much, much later. Like academia's really kind of research things, but with AI, it's quite different. Some of the times we see academic papers published, and then there's something there that they can commercialize almost right away. And the advantage of the commercial vendors is they can take that application specific expertise. And many people forecast, and I'm probably part of that group too, that the big transformations you're going to see in AI are from people who can take application-specific knowledge and marry it with AI. They will produce more transformative applications than Google or Amazon or Azure, because they are kind of general providers of the platform. They don't have industry-specific knowledge, although that is changing. You'll see Microsoft's investing in a healthcare cloud. Same with Google. So there are some exceptions there because they go, hey, that industry is really quite profitable as they march toward that. But let's say manufacturing. None of them have a manufacturing specific line of business. So the real breakthroughs there will come from a company who goes, there's something I think we can improve here in manufacturing. That subject knowledge combined with AI, either commercial or open source, those are the ones to watch out for.
That's very good. Arizus Abed and then Karen Kirby both say fantastic content and industry depth. So thank you. And Arizus Abed specifically is asking if you can elaborate a little bit more on the approach you took to overcome the data siloed mentality that you find on IT people. How do you overcome that? 'Cause it seems that maybe she may be experiencing something similar.
Yeah, and unfortunately, it's not easy. What we had to do was we had to go to the highest C-level in IT. So in this case, it was a CIO, and we had the line of business and their C-level exec. We had to get them to kind of agree, and then that percolated down. If you worked at the working beat level, they're just going to follow their mandates. They're not either going to share or they're going to want to share and in a way that IT won't allow it. So unfortunately, yeah, not an easy thing. And sometimes if there's a independent person, a trusted advisor somehow, which was what I was brought in as, they go, okay, I didn't really have a bias of whomever. I wanted something that was best for the firm. And so going back to, again, what helped them was understand what is the business vision of the hospital. So in this case, my case study, it was be a teaching hospital, research hospital, but patient care. And it's those things at that level you have to remind the IT folks and remind the line of business. We're all in this together, right? Here's the things here, and let's try to align it so that we're all play nice together. So yeah, understand there'll always be a challenge.
Thank you, Bill. It's always a masterclass with you, whether it's artificial intelligence, data analytics. You're one of those few leaders that combine the technical expertise with the collaborative approach in your leadership, and it's highly effective. It's a blessing for all of us to have an opportunity to learn from you and share it with you. So on behalf of our global community, I want to say our deepest thanks and appreciation for you to share your expertise with us.
Well, thanks again, Jose. Always look forward to meeting you and your clients, and grateful for this time and glad I could assist.
Thank you, Bill.
Cheers. Bye.
Ladies and gentlemen, that's Bill Wong, leader of artificial intelligence and data analytics at Dell, directly from Toronto, Canada, to our global audience. Always a masterclass on artificial intelligence, data analytics, and enterprise architecture and technology related fields. We are going to take a break. And then when we come back at the top of the hour, we'll have our last session of day one of Enterprise Architecture Live. And we're gonna bring you another tremendous practitioner. I'm talking about Andrew Seifer, who's Director of Actuarial Data Governance for Nationwide. And Andrea will be talking about designing a customer-focused governance model that aligns the business architecture for competitive advantage and continuous improvement. So again, a real industry practitioner, not only talking about these concepts, but living the implementation of these disciplines and in the organization. So taking a break now. I'll see you all back at the top of the hour. Thank you.